Let's start. Hi, everyone. Welcome to JuiceFS Office Hours number 3. It's great to have you all with us today. I'm Ray Su, co-founder of JuiceFS. For anyone who's new here, please let me introduce. JuiceFS is an open source cloud-native file system that's designed for performance and flexibility on the cloud. We have 3 editions, the Community Edition, Cloud Service, and the Enterprise Edition for private deployments. Our Community Edition is open source and has already earned over 12,000 stars on GitHub. And from our observation, about 20% of deployments in the United States. Our cloud service is currently going through a SOC 2 compliance audit. We expect to complete it before Christmas, or maybe even sooner. And Enterprise Edition gives you full flexibility to deploy wherever you want, on-prem or across cloud. And today's session kick off our hands-on workshop series. And since this just a third office hour, we're still starting from the basics and help new users get comfortable installing, configuring, and benchmarking JuiceFS. And if you can't stay for the whole things, no worries. The replay will be up on YouTube soon after. All right, let's get into the fun part. I'll hand things over to Qingjiang, our North American SRE lead, who's going to do a live demo to show how to set up JuiceFS on AWS and run a simple benchmark to check if everything is running smoothly. So, Qing, the screen is yours.
Thank you, Su. Let's get started. So today's session, I'm going to show you how to download, install, and set up JuiceFS and do some benchmarking. So first, let's go to JuiceFS.com. So we're in here. And as you just mentioned, we have Community Edition, which is the focus of this session. We also provide cloud services as well as the enterprise deployment, which we may cover, follow-up sessions. So let's go to the documentation. Quick start installation. That's the essentially the starting point of any new JuiceFS Community Edition users. And it's quite straightforward, including a one-line installation of the JuiceFS client. So let's go ahead to copy the command into a console. There's the machine already been prepared for this demo. Let's go ahead and run this command. So it will download the latest version of JuiceFS client into your local machine. And since it's a file system, we recommend that you run as a root user or use sudo. So download is done. Let's check out the version. Okay. So that's the installation of the client. And before we dive into the so-called the meta or other settings, let's go back to the document side to review the architecture. As you can see here, we already just one command install the client, and essentially this, since JuiceFS is a POSIX compatible system, so you can use it as like a normal file system as you get used to. And we also support other way to using JuiceFS. For instance, you can interact with JuiceFS using Java or Python SDK. And even run it through as a storage provider through the CSI driver in Kubernetes, and you may even enable this like a bucket using our S3 gateway, right? So that's the client side. We already installed it, and then in the bottom we have two parts. One is so-called metadata, which essentially store the file system's metadata in the backend of your choice. So currently we support Redis, PostgreSQL, TypeKV, MySQL, and along with others. And for this demo, we are going to using Redis, which we all are familiar with, as our meta engine. And for the storages, we're going to using AWS S3. We go to the rest of them, including Google GCS and other popular S3 object storage vendors. Yeah. Okay. So for the metadata setup, essentially you just need to install the database, right? So in this case, it's Redis, and we already have it up and running locally as a Docker image. And for the data storage, I have created a bucket called JuiceFS Office Hour 01 as our object storage. Right? And like I said, we support other different type of metadata as well as storage. And for the comprehensive list and how to set up, you can go to the reference. And for the metadata, we have this how to set up metadata engine under the reference, right? So you can see here we have Redis. It shows you the different URL pattern, for like secured Redis. Redis needs username, password, Redis cluster, or even connect to a val key, which is compatible of Redis from AWS, right? And as well as other key value databases, for instance, the TypeKV, which is very popular in open source key value implementations, and as well as the SQL database, for instance, MySQL, Postgres, and even the SQLite, which is very is set up essentially a file-based SQL compatible implementation over there. Okay, that's the list of the metas we currently support. And for the object storages, of course, we support AWS S3 and the ending S3 compatible storages, right? So, a lot of third-party storages that like compatible with S3 protocol. Then we, high chance we can support them as our backend storage. And for the others, for instance, the Google Cloud, Zoom, and other popular clouds like R2 from Cloudflare. We actually have a very big customer in North America using R2, and Orange Cloud, object storage, etc. So there's a list, and maybe they have some different kind of endpoints. So we in this document, again under the reference, how to set up storage, object storage, and you can browse in all the currently support and the test object storage vendors, right? And for any vendors which not in the list, if they say they are S3 compatible, it's highly possible we support them. And we also provide tools to test the complexity, the compatible of that object storage, which I will get to it later on this demo. Okay, so since we already have Redis as our meta and a S3 bucket as our storage, we can go ahead to format the file system, and the command of something like see. Yeah, something like this. So using the JuiceFS client we just download, we type JuiceFS format and the storage type and your meta URL, and then the name of your file system, or we call it a value. Okay. So I already have these commands written down. So I just copy it here. So the format is run successfully. That shows you I'm using this meta address here. I format this S3 bucket, and this is the result. Okay. And if we go back to our object storage, refresh, and you can see the name of the file system or the value name. It's created as a folder inside the bucket. This demo 001. And we have some metadata already being written into that thread folder. Okay. Okay, so we have this file system formatted. So the next, naturally, well, we are going to mount this file system and starting to use it. Right? So the next command will be JuiceFS mount, and with a the meta URL and then a mount point, as you know, as you may create as a folder, an empty folder as a mount point, which you guys may already familiar with. So okay, this mount is success and is ready to use, but it's a from command. So I need to run it as a background so I can type other commands. So I just mount it as a background, and then we can go to this file system. It's currently acting, but we already have some the pre-create management folders over there, but you can essentially ignore these folders. I can go ahead to create a new file. All right, so the file is created right here. And then if we go back to our, like I said, all the data, it's actually stored in the S3 bucket, and the meta, the information of the file is in Redis currently. So if we go back to the bucket, and you can find there's a chunks, there's a goofy folder over there. So let's go back to display the architecture part, to display, how this folders layout is, because we to achieve high performance when we using a object storage as a backend. You guys know there's a limitation of object storage, and to actually to using the object storage as a native file system and achieve high performance. And that's how the JuiceFS is being invented. And you can see that this architectural section of this document is actually talking about a little bit about how we spring the large files into slice, chunks, and blocks, and store in the object storage. So I leave to you guys to go through all these, decide principles and the details and how we organize the files, right? But we already have this file system running, and you can start to use it, like a local file system, but you have unlimited storage technically because it's better than its object storage, right? Okay, so we talk about this high performance a lot, but we really want to know how fast this JuiceFS system as object storage as a backend can be achieved. So the next session we are going to do some performance test. But before that, let's again go back to the documentation because they have everything in our document. So the first, if you go to the benchmarking and the profiling and the performance benchmark, and there's a whole section dedicated to how to test the performance of the JuiceFS system, including our own tools and third-party tools to run the performance test. So let's go to our old tools first. So there's a subcommand called JuiceFS bench. So we are going go ahead to run that. And the subcommand have this option called -p, means parallel or concurrent jobs is running. So the for is like 4 concurrent jobs is running to do the bench. And here comes the result. It's not bad. When you write a big file, it can achieve like 710 megabytes per second, and even faster for the read, which is 1 gig per second. Not bad, isn't it? So that's the JuiceFS bench, and we came also to test the storage. Like I said before, maybe you want to using some third-party object storage which claim they are compatible with S3, but if this true or not, or how fast they are, right? So we have another subcommand called object bench, right? It's not testing the JuiceFS system itself. It's just test the object storage directly, right? So the command is similar. It's object bench -p again for concurrent jobs and the storage endpoint, right? Let's go ahead and run this command. Okay, you can see the result here. So first we do some so-called the function or compatible test. So all these basic catalogs, right? Well, it's really important. If we fail in any of those, could be an issue. But this part should be fine. But yeah, so this is a compatible test for the storage object storage endpoint, and the next session will be the real performance for that object storage. And you can see this a little bit lower performance here because the JuiceFS actually improved the performance. But you directly test the object storage is maybe lower. So this is the result. And we can essentially, like I can, really try to squeeze the capability of the object storage. So we can, probably increase the concurrent worker, from 4 to 8, and let's see what happens. So again, it's functional test first, and then you're using a concurrent workers to test the object storage. Okay, you can see there's a little bit, improvement of the storage. So that's conclude the benchmark. And all the, parameters or examples can actually, you can find in the document. Oh, I forgot one part. It's the third-party test. It's really important because you are using our own command to test the performance and it shows. Then what about the third-party, results? So one of the very popular command to test the file system performance is called FIO, and FIO can even test the more write or read patterns. For instance, the sequence write or B file sequence write or random read or small file random read, things like that. So we including a list of the examples for running the FIO, sorry, the FIO, and I'm not going to through each of them, but I will give you a very quick a command to run one of them here. So again, it's pointing to the JuiceFS mount point with different settings. Like the size of the file, concurrent jobs, deep over the directory, etc. So this command will run it's for 1 minute. So maybe we can remove that 1 minute, just give you a quick result. So let me remove that command and just give a quick result. So we can check out the result real quick. Okay, here it comes. So we have this IOPS. Obviously, that's 600. That's not bad. Okay, and there's some write speed of 600 megabytes per second. Is consistent with our JuiceFS bench. Remember, we also achieved that write speed. Okay, that's the FIO. So when we talk about the benchmarking, we probably want to watch the benchmark like consistently when you put the JuiceFS into production, right? Then comes the whole section of doing the monitoring. So when you go back to the document, you go to the administration and monitoring and the data visualization. We actually provide a metrics endpoint, so you can scrape that metric using Prometheus and then pumping into Grafana to get this nice dashboard. We also provide some building dashboards you can use, so you can monitoring the performance of your whole file system. And we also provide some of the so-called real-time monitoring using the command line tool, and I would like to show you now. So this real-time performance monitoring tool, that's not involving using Prometheus Grafana, because you need to set out this tool. This performance command line is just run in command line and it show you in the console, right? So these two commands, one is JuiceFS profile, so another one is JuiceFS states. So let's go to our terminal again. This time need to using Tumix. And split them into two plane. And the first one, we will run our old friend FIO again. So it's gonna doing some writing. And then if we do a JuiceFS states, it's gonna show you, let me get some more data out. It'll show you the real activity, in the IO path, including the fields tier, the meta tier, the object storage tier. You can see the how many operations and what type of operations and the latencies, right? So there's a lot of data over there. But you probably say, okay, I don't know where I can look at. So, but don't worry. The document actually, explain everything, where you should look at, like how many latencies has been spent on the, query, the meta engine, in our case, it's Redis, right? And then how many time is being spending on the object storage and the number of gets and number of pulls and things like that. So everything is pretty exclusive, carefully. Completely under this JuiceFS states performance testing. It's under the again the performance benchmark center of our documentation. I would say we have a very comprehensive document site over there, so you can essentially get everything there. And if you have questions about specific things, you can also join our Slack channel to like to answer the questions over there, and hope it can help you to get advanced into the JuiceFS world. Okay, that concludes today's demo. Thank you, everyone. Let's open the Q&A and see if you guys have some questions.
Okay, thank you, Qing, for the great demo and walkthrough. We'll be publishing the replay. Sorry, the dog is noisy. We'll be publishing the replay on our YouTube channel. So if you'd like to revisit the session and catch future workshops, please subscribe or to stay updated. Our recent office hour focused on the open source community edition. But if you prefer not to manage infrastructure yourself and just want a fully managed worry-free experience, you can try JuiceFS Cloud Service. If you have any question about that, feel free to reach out via JuiceFS.com or join our Slack channel for support. Now we have opening up the live Q&A session. Please post your question in the YouTube chat. We'll repeat and answer them there. Here. All right. Yeah. I think that's all we have for today. Thank you everyone for joining JuiceFS Office Hour number 3. And we really appreciate you spending your afternoon with us. If you're enjoying this session, make sure to subscribe our YouTube channel. So if you don't miss future workshop or demo session, you can also join our Slack channel to chat with team and other users. We're always happy to hear you feedback and help you troubleshooting real world use cases. And of course, don't forget to follow JuiceFS on LinkedIn or X for updates, user story, and even event announcement. Thanks again for being here. Have a great evening. See you next time at JuiceFS Office Hours. Bye.